Hello and welcome to the Daily Space. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. Our first story is one that demonstrates yet again that science is as much about creativity as it is about careful work and following the scientific method. A new paper in Nature Geoscience points out that underwater landslides can be caused when massive icebergs run aground or otherwise hit or scrape outcrops in the seafloor. There are other triggers as well, but in this new era of melting sea ice and fragmenting ice shelves, this new piece of knowledge points to a potentially hazardous future. At the extreme end, undersea landslides can displace large volumes of water suddenly and send a massive tsunami through the sea. While less extreme, these events can also destroy rare and sensitive ecosystems and damage undersea cables. This discovery was made almost by accident. Researcher Alex Namandu was on a research trip through the Baffin Islands Southwind Fjord and snapped a bunch of photos of a random iceberg. The trip was actually to look for landslides, and while none were observed during that trip, it was noted on a return trip that one had occurred shortly after the initial voyage, and it was located near features that looked like the scraping of an iceberg running aground. Using satellite data from Sentinel-2, the research team realized that the original random iceberg was the trigger of that new landslide. And now, every iceberg, we realize, is a danger to both the things on, in, and above the water. The more you know. A while back, it was realized that Venus likely had a rather Earth-like environment for a while, and then for unknown reasons became the acidic furnace of destruction it is today. The fact that we don't know why is something that would keep me awake at night if there weren't all the other things already keeping me awake at night. Superrotation. Venus's atmosphere has a weather pattern called superrotation that causes cloud patterns to move so fast east to west that nighttime IR imaging, something we do on the regular here at Earth, it couldn't be done without implementing special data reduction techniques that allowed researchers to digitally track their images with the atmospheric motion. Once that superrotation was accounted for in image analysis, infrared data of the nighttime side of Venus showed additional massive winds. This data came from Japan's Akatsuki orbiter, and team members Amaru explains, "We are finally able to observe the north-south winds, known as meridional circulation, at night. What's surprising is that these run in the opposite direction to their daytime counterparts. Such a dramatic change cannot occur without significant consequences. This observation could help us build more accurate models of the Venusian weather system, which will hopefully resolve some long-standing unanswered questions about Venusian weather and probably Earth weather too." I'm really hoping that in understanding Earth better, we don't discover superrotation is in our future. There are some things we just don't need to experience for ourselves. And now for something entirely different. The Asteroid Terrestrial Impact Last Alert System, or ATLAS, has so far not found anything looking to hit Earth and destroy life, a fact I am grateful for. It has, however, found a lot of comets, and one of these comet atlases, the Comet C 2019 Y4 Atlas, promised us a great celestial show in 2020, and then fell apart instead. Literally, the main body of the comet, which appears as the round head from which the tail expands back, that head shattered, and the debris was left as an orbiting mess. A mess that just happened to orbit right into the path of the European Space Agency's solar orbiter. The instruments on this mission allowed researchers to determine that cometary fragments reshape the sun's magnetic field. Essentially, the magnetic field drapes itself around the fragments, helping to shape comets' ion tails. Project lead Lorenzo Mattini explains, This is quite a unique event and an exciting opportunity for us to study the makeup and structure of comet tails in unprecedented detail. Hopefully, with the Parker Solar Probe and Solar Orbiter now orbiting the Sun closer than ever before, these events may become much more common in the future. Yes, folks. He's hoping for more comets to self-destruct in the inner solar system and get close to solar probes. Science is weird. It is also wonderful. And after the break, we're going to look at what science has to tell us about the inside of Mars. Stay tuned. It has been an exciting week in the world of space science, with some revolutionary stories being published. Next up, we look at the results from 3 separate papers released this week in the journal Science on the structure of Mars. The teams involved analyzed data from NASA's InSight lander. Remember how we told you about how InSight's seismometer detected hundreds of Mars quakes? Similar to how we used earthquakes to understand the internal structure of Earth, these teams, they did the same for Mars. First, scientists had to work based on the assumption that Mars might be similar to Earth, with a series of layers, the crust, the mantle, and the core. It's a little more complicated than that, but it's a good basic starting point for understanding a planet's structure. And as lead author Amir Khan explains, now seismic data has confirmed that Mars presumably was once completely molten before dividing into the crust, mantle, and core we see today, but that these are different from Earth's. Let's start at the surface and work our way in. The crust under InSight, which is near the Martian equator, is between 15 and 47 kilometers thick, which is relatively thin compared to Earth, where the crust can be up to 70 kilometers thick. It also means that the chemical composition of the rocks may be more radioactive than those here on Earth. Under the crust is Mars' mantle. Here's where it got a bit interesting. Like Earth, Mars has a lithosphere at the top of its more plastic, flexible mantle. That lithosphere is twice as thick as that on Earth, ranging from 400 to 600 kilometers deep. Unlike Earth, Mars appears to only have one continental plate, opposed to Earth's 7 large ones and numerous smaller ones. This structure could explain why we don't see signs of plate tectonics on Mars. As for the composition of the mantle, the Martian mantle is similar to Earth's upper mantle, although it does seem to contain more iron. Finally, we come to the core. No, not that terrible disaster movie from 2003, but the innermost layer of a planet. Researchers were able to use the seismic waves detected by InSight to calculate the size of the core, and per the press release, the Martian core has a radius of about 1,840 kilometers, making it a good 200 kilometers larger than had been assumed 15 years ago when the InSight mission was planned. Co-author Simon Staller goes on to explain, if the core radius is large, the density of the core must be relatively low. That means the core must contain a large proportion of lighter elements in addition to iron and nickel. So, within Mars' core are lighter elements like sulfur, oxygen, carbon, and nitrogen. But that core is still liquid as researchers expected, which is a bit surprising given that Mars doesn't have a magnetic field anymore. InSight has done some amazing work despite the failure of its drill, and we're pretty sure there is more to come, which we will continue to bring you here on the Daily Space. After the break, we'll be back with some more amazing results and observations involving exoplanets. Stay tuned. You never know what data is going to surprisingly teach you new things. In a recent study of the atmosphere of the exoplanet TYC 8998-760-1b, researchers were able to learn about the planet's history from the kinds of atoms in its atmosphere, or more to the point, from the kinds of carbon atoms in its atmosphere. Carbon is a pretty stable atom that has 6 protons and usually has 6 neutrons in its core. Sometimes, however, it can end up with 7 neutrons and become carbon-13. And to the joy and usefulness of archaeologists and paleontologists, it can sometimes end up with 8 neutrons and become the ever unstable carbon-14 that is used for radiocarbon dating. In looking at the atmosphere of this boringly named alien world, researchers expected to find about 1 in 70 carbon atoms would be carbon-13. But instead, they found 1 in 35 atoms were carbon-13. Researchers explain in a new paper appearing in the journal Nature and led by Xiaoping Zhang that they believe this difference may be due to the planet's extreme distance from its sun. Co-author Paul Moilier explains, "The planet is more than 150 times further away from its parent star than our Earth is from our sun. At such a great distance, ices have possibly formed with more carbon-13, causing the higher fraction of this isotope in the planet's atmosphere today." This is admittedly a sample of one. We're going to need to study a lot more planetary atmospheres to know if this is the norm or just one weird world in a universe that refuses to be normal. Also on the exoplanet front, new observations published in the astrophysical journal Letters showed that there is a potential exomoon forming around an exoplanet, and we have images. Using the Atacama Large Millimeter Array, scientists detected a circumplanetary disk around exoplanet PDS 70c, which is a Jupiter-like planet orbiting a star about 400 light-years away. This disk surrounds the planet, similar to how protoplanetary disks surround a star, and it's full of dust that could be turned into a moon, an exomoon. And we have managed to get a picture of that disk. What a time to be alive, people. Here's what we basically know of planetary formation. The details get murky, so this is simply an upper-level understanding. A star forms and is surrounded by a circumstellar disk full of dust. That dust can then coalesce into planets, which will pull more and more dust and debris into them and grow as they collect material. Not all of the dust ends up in the planet, but can turn into a circumplanetary disk of dust that now orbits the planet, orbiting the star, and could similarly coalesce into a moon or 3. Lead author Miriam Bensity commented, "Our Atacama Large Millimeter Array observations were obtained at such exquisite resolution that we could clearly identify that the disk is associated with the planet, and we are able to constrain its size for the first time." The diameter of this moon-forming disk is comparable to that of the Sun-to-Earth distance and contains enough mass to form no more than 3 satellites the size of our own moon. Now, there is another Jupiter-like planet called PDS 70b in the system. The 2 planets seem to possibly be a Jupiter-Saturn type of pair, but 70b doesn't have any evidence of a disk. That could mean that 70c starved its neighbor of dust while they were being born. Not very nice. But we could be wrong. With further observations from the upcoming extremely large telescope giving us even more information about this system, hopefully we'll figure out what's going on. We're going to keep journeying out into the universe. After this last break, we'll look at a galaxy jet. From planets, we now jump to planet-sized telescopes. The Event Horizon Telescope has released new super high-resolution images, this time of the inner details of the galaxy Centaurus A's jets. The Event Horizon Telescope is a collaboration of radio telescopes all across the globe that work together to observe targets of interest. This collaboration has previously shown us the twisted light that is warped around M87's central black hole. Now they look out a bit further from the center of a different system. Centaurus A is an active galaxy. This means material, dust, gas, stars, even planets have been driven into the galaxy's center by some sort of a collision or similar, and as they spiral in toward the galaxy's central black hole, things get denser. They heat up and essentially form an electromagnet that sends jets of particles out of the north and south magnetic pole of the galaxy. We see these jets extending hundreds of thousands of light years in the radio, and deep images from scopes like Hubble show features down to hundreds of light years. And now, we can see details with the Event Horizon Telescope smaller than one light day across. To put this in perspective, I'm going to quote from the press release. With the resolving power of the Event Horizon Telescope, we can now link the vast scales of the source, which are as big as 16 times the angular diameter of the moon on the sky, to their origin near the black hole in a region of merely the width of an apple on the moon when projected on the sky. That is a magnification factor of 1 billion. Let me state that even more clearly. Had an Apollo astronaut set an apple down on the surface of the moon, and had that apple been a source of radio waves, this telescope could have resolved it. And it did resolve details that size on the sky in this distant galaxy. What shocked me, and apparently also the research team, is that the jets have this odd illumination of the edges only. And this is consistent with the jets being cones of particles, which are easiest to see at the edges. We've seen this to a lesser degree in other systems, but as collaborator Sarah Markov states, we found it challenging to explain with the same models we used with M87. Something different must be happening, like helical magnetic fields, which give us new clues about how they may squeeze the jets. This data intriguingly points to the exact location of Centaurus A's central black hole, and the research team thinks that future observations will be able to add in this central detail. The only thing slowing them down is the need to extend their network to space. Sometimes an Earth-sized telescope just isn't big enough. There are currently numerous plans to seek funding to build both orbiting and lunar telescopes. And I'm hoping we are less than a generation away from mapping the core of this active galaxy. This has been the Daily Space. You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.